Hi, people. Hope you're doing great. Hey, here we are. Guess what? We made it. End of chapter 7. Hardest chapter we've had yet. Bad news. Next chapter is going to be even harder. Sorry. We'll make it through together, though. I promise. Anyway, let's get into... this is... we've seen sequences before. What was our first sequence we saw a long time ago? Started with an A. Not awesome sequence. They were awesome, but they were also arithmetic sequences, okay? So this is their, friend, their sibling, okay, geometric sequences. And just like we had a common difference with arithmetic sequences, here we have a common ratio. So difference we found by subtracting, ratios we're going to find by, you guessed it, dividing, okay? So let's see that in action. Here we go. So as usual, first thing we'll do is just identify, hey, are you an arithmetic or a geometric sequence? In order for me to do that, we're going to take this first term minus this term. So 8 minus 0 is 8. 16 minus 8, also 8. 24 minus 6, 8. 32 minus 24, 8. Okay? When we subtract and we keep getting the same number over and over, we call that a common difference. And this sequence, my good friends, right, is arithmetic. Okay? Bam, easy peasy. I think at least. Okay? All right, next one. Here we go. Same question, right? Same kind of question. All right, so we're going to do some subtracting here. 48 minus 64. Okay, what is that? Negative 16. 36 minus 48. Negative 12. Okay, I can stop right here. This is definitely not arithmetic, right? Or I would keep getting the same number here, okay? Scratch this out of here. Let's take a look. Geometric sequences, guys. Look, all we do is take 48, divide by 64. In this case, we're going to get a fraction. Let's see. I think that should be 3/4, right? Yeah, this should be 3/4, okay? Do the same thing here, 36, divided by 48, divided 12, yeah, 3/4, aha. 27 divided by 36, divide a 9 out of there, 3/4. Guess what our common ratio is, gang? 3/4, you got it, okay? 3/4. So we determined it's geometric, right? They didn't ask for it, but the common ratio in this one is 3/4. They're going to ask for that here eventually. Same thing here. Again, I'm looking at subtraction. No, I can tell you right now, look, that minus that is 6. This minus that, definitely not 6. So you are not arithmetic. Okay, let's do our other tricks. 7 divided by 1 is 7. 49 divided by 7, also 7. 343 divided by 49, 7, okay? You can't just stop after the first couple and say, oh yeah, this is good. Because look, eventually I'm going to try to sneak in some number down here that is not going to give you that same common ratio, okay? So this one, geometric. All right. All right, so let's do our subtracting here. 2 minus 1 is 1. 4 minus 2, 2. Don't need to go anymore. You are not arithmetic. Okay, let's look at geometric. 2 divided by 1 is 2. 4 divided by 2, aha, there we go. And then I get this problem child. 14 divided by 4 is not 2. So this is neither, right? You are neither arithmetic or geometric. Sorry, you lose. Okay? Guys, that's the end of the day. Time to go home. For you, not for me, there is still work to be done here. Okay? And the rest of our work involves weird stuff like this. Positive number, negative number. Positive number, negative number. This can't possibly be a sequence. Can't possibly be a sequence. Okay? Wait a second. But they're telling me, find the next 3 terms of this geometric sequence. Okay. Well, the first thing I need to do is figure out my common ratio. So again, negative 8 divided by 1, negative 8. 64 divided by negative 8. Also negative 8, okay? Negative 512 divided by, whoa, I was going to put 8 on there. Divided by 64, negative 8, okay? So what is my common ratio? It's negative 8, all right? Now, if I want to figure out what my next terms are, Okay? We're not going to divide, right? We've been dividing to figure out this number. We're going to multiply. So, and if you're not sure, go back and see if this works. 1 times negative 8 is negative 8. Negative 8 times negative 8, positive 64. Interesting, that's how this works. Times negative 8 is negative 512. So there we go. So negative 512 times negative 8, guys, is a very large number. So here's my next three terms, 4,096. Okay? I'm going to multiply that number by negative 8. Now I'm going to get that negative 32,768. Again, going to multiply my last term by negative 8. I get 262,144. Bam. There's your next three terms in that sequence. That's how easy it is. We always find our common ratio, and then we're just going to multiply to keep finding those extra terms or those successive terms. Okay? Same thing here. Again, you think you guys can handle this? You just go right ahead. You pause this thing. You write in the next three numbers. Step 1, though, figure out your common ratio. 20 divided by 40. 1/2. 10 divided by 20. Also 1/2. 5 divided by 10. Also 1/2. Okay? So there is your common ratio to figure out your next terms. Okay? I'll take 5 over 2. Multiply by another half. Now it's 5 over 4. Multiply by another half. Now it's 5 over 6. Okay? No, 8. Who are you kidding? Who are you kidding? Okay. Whew. That would have been bad. Okay? At least I think all those are right, folks. It's late in the day. Be multiplying fractions in my head like that. But I think all those are good. Okay? If not, take them up with me at a later date. Good to go. Next three terms. Again, find your sequence here. Find your common ratio. Second term divided by first term. Negative 5 divided by 1 is just negative 5. 25 divided by negative 5. You guessed it. Negative 125 divided by 25. Still negative 5. So there's your common ratio, negative 5. Go ahead now. My next three terms. We're going to take this one, multiply it by negative 5. That's going to give me positive 625. Multiply that one by negative 5. We're going to get a bigger number here. Negative 3,125. Okay? And to get our last number, again, multiply by negative 5. And this should be 15,625. Bam, bam, bam. Okay? So there you go. So there should be some good practice for us on identifying geometric sequences, finding the common ratio, right, and then going ahead and finding the next three terms. Now, as of course you guys know, get that out of here, they're going to want us to do, look, this one's more of the same, guys. This one has a common ratio of 2, 8, 1/4, right? So just multiply all these numbers by 1/4. So 25 over 8, 25 over 1/4, right? 25 over 32, and then 25 over 128. And maybe, that could be wrong on that last term there. Anyway, you guys can have fun with that one. Yes, here we go. This is what I want to get to. Zoom in. Why are you not zooming in? Okay, thank you. Voila. There is our handy formula, folks. Right here. We just need to understand each part of it, okay? The nth term, here it is. This is the term I'm trying to figure out. Hey, I want you to find the 28th term, the 72nd term, right? We would say A28, A72, okay? Equals, A1 hasn't changed. It's still a great steak sauce for those of you that like it. Also, the first term, though, in math, okay? So this is the first term of our sequence. R, that's our good friend, the common ratio we've been finding. N is just the number, the term number we're trying to find. So if we're trying to find the 30th term, N is 30, okay? This N and that N are always the same. If you're trying to find the 30th term, you're going to write A30 equals first term times your common ratio. Again, this is to the power of n minus 1. So whatever that term is, 30 was my example, 30 minus 1 is that 29, okay? So ratio to that power. Okay, let's put this to use, okay? Here it is. Write an equation, my most favorite thing to do, for the nth term for a geometric sequence for this. So I don't have to worry about the arithmetic one. It's told me it's geometric. What's my common ratio? Negative 2 over 1 is negative 2. 4 over negative 2, yep. Negative 8 over 4, yep. Okay. We just got to double check that we do indeed get the same common ratio for all this, which we did. Okay. So common ratio equals negative 2. Okay. Here we go. AN equals A1 times R to the n minus 1 power. Fill in what you know. Okay. Well, what we know is this. The nth term is equal to the first term, 1. Common ratio, negative 2 to the n minus 1 power. Good to go. Okay? There's really nothing to simplify. Unlike before, when we had to distribute, right, the common difference and then combine our like terms, this is beautiful, right? I don't need to do anything else here. We can leave it just like this. In fact, guys, you can even write it without this one. If you wanted to be super fancy, right, I'm sure, the fancy people that wrote our book, if they were giving you the answer, would just give you this right here, right, which would be confusing because you'd be like, hey, where did the first term go? There's got to be a first term. It's just 1, okay? All right. Now you see why I like geometric sequences way, way more better, okay, than the other ones. Find the 12th term. I wish I could bring back all of our stuff. There it is. Welcome back, okay? So now I want to find the 12th term, okay? So we're going to take this, and here, I'll just write it over here. AN equals, I'm going to leave the 1 on there just to show to you that it really doesn't do anything. N minus 1. Okay. Make all this go away. Got it. Okay. If we want to find the 12th term, that means n is the number 12. I see 2 n's. I will replace each one with 12. Right? And guys, A12 just means the 12th term. That's all it means. So the 12th term is equal to 1 times negative 2 to the n minus 1 power. Okay? 12 minus 1, I believe that to be 11. Okay? There you go. And we just need to figure out what number this turns into. You can literally type that whole thing in there, guys. So I'm going to take 1, even though it's not going to change anything. Negative 2 to the 11th power. Bam. There is your number right there. So the 12th term, or A12, is, negative 2,048. Okay? Way easier than finding my common difference and multiplying out a whole bunch of times. Well, let's be honest, 12 wouldn't be too bad, right? If it was like 22, something crazy, that'd be annoying, okay? All right, same thing here. Step 1, find your common ratio. Find your common ratio. So negative 12 divided by 3. Okay, 48 divided by negative 12. Okay, 192 by 48. Yep. Common ratio is negative 4. Okay, we can go ahead and write our formula. The nth term is equal to the first term, 3, times the common ratio to the n minus 1 power. There it is right there. Now I can find any term you would like me to. Would you like me to find a term for you? I bet you would. Okay? They would like the 7th term. Oh, look, guys, hey, look, we wrote it right. We are awesome. Okay? So, yeah, if we're going to find the 7th term, just going to look like this. A7, that means the 7th term, is equal to that 7 minus 1, which, of course, we know is 6. So, again, calculator time. 3 times negative 4 to the 6th power. Okay? I get a crazy small negative number right there. Yep, so the 7th term Negative 12,288. Fantastic. Okay. Couple more, guys, and we're out of here. Alrighty. A 50-pound ice sculpture is melting at a rate in which 80% of its weight remains each hour. Draw a graph to represent how many pounds of the sculpture is left at each hour. To draw a graph? Ugh, okay. Guys, when we draw graphs, and look, I'm not going to draw a crazy accurate graph here. Okay, where are we starting? Well, we're starting at 50 pounds, okay? So we have 50-pound sculpture. It's melting at 80% of its weight remains each hour, okay? So your term numbers, right, are just on your x-axis. So like first term, second term, third term, fourth term, okay? The weight, right, is going to be whatever number that is. That's going to be our y number, okay? So 1, 2, 3, 4, 5, right? I don't really know how far out they want us to go. 4, 5. I mean, eventually the sculpture is going to melt. Is it ever going to go away, though? In theory, no, right? If only 20% of it goes away each hour, you'll never get down to nothing. Doesn't make sense, though, right? It should evaporate. Anyway, whatever. Okay, we know we start at 50, right? So here is 50 all the way up here, okay? First time, we're just going to plot all of these points on here, okay? So we're going to lose 80% of our weight, right? So you can think of this as AN equals starting amount. Now, if we think about how would we find the second term? We know we start at 50, right? How am I going to find the second term? Well, we're going to multiply this by 80%. Not really 80%, but 0.80, okay? You can think of that as your common ratio, okay? There you go. Beautiful, okay? So shall we do that? We can keep doing this, right? So 50 times 0.8, so now it's going to be down to 40 pounds, right? So oh boy, I got to try to estimate 40 and 30. Oh, I did not do this very good. You guys are going to laugh at me. Okay, anyway, you get the idea. So guys, next term, we're going to go ahead and plot at 40. Again, then we're going to take that, multiply it by 0.8. Now we're at 32 is my next one. 32, again, multiply that by 0.8, right, which is that common ratio. Now you're at 25 and a half, right? And you can see, right, these are going to keep going down. Well, anyway. But that's all. If they're just asking for a graph, guys, that's what we're going to do. I don't know that I would ever ask you for a graph, but in that case, they did. Let's get to some more word problems. This is our last one. Boo-hoo. Right? I enjoy these. A soccer tournament begins with 32 teams. I was going to say themes. That doesn't make any sense. In the first round. In each of the following rounds, one half of the teams are left to compete. Okay? Until only one team remains. Draw a graph to represent. Okay, I don't want to draw a graph, guys. I want to write the equation for this. Okay? All right. All right. So we start with how many teams? Yes, 32. Okay? And how many are going away after each round? Yes, okay? So we start with 32. After the first round, guys, there's only 16 teams left, right? So you can think of it as say, hey, 32, then 16, then 8, then 4, then 2, then the winner, okay? So if you need to think like this to say, okay, yeah, we started here, okay, 16 over 32, 1/2, okay? 8 over 16, there's my common ratio, 1/2, okay? Go ahead and write this equation for the nth term now. So 32 times 1/2 to the n minus 1. Again, n is however many rounds you're having, okay? So like in the first round of the tournament, we had 32 teams. In the second round of the tournament, it went down to 16. In the third round of the tournament, now I'm at 8, okay? So if we were going to plot that, I mean, I guess we could make this. So first round, second round, third round, fourth round, okay? We're just, how many teams do we have? So this is 1, and I'm just going to say this is 32. So you're just going to have a dot there. And then you're going to have 2 with 16, okay? And then 3, maybe here's 8, okay? And it's going to look like that. Again, graphs of sequences are, I think they're dumb. Shh, don't tell anybody that, though, okay? But that's what they look like. They're literally just a dot, right, for that term number, which is always 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so on. And then whatever the value, right, is, or the number that goes with that term, okay? But yeah, I'm more hopeful, guys, we can write this from this. Again, looks very similar to our y equals ab to the power of x, doesn't it? Yeah, it kind of does. Starting quantity, growth rate, okay, so that's kind of similar, right? The n minus 1 thingy, well, that's new. Anyway, you guys should be completely dangerous now to do all things geometric sequence related. So that would include our Math Excel, that would include our bookwork. Again, if you need practice on this stuff, guys, use the skills practice, right? Maybe you just want to work on a couple of the writing ones. Do that, okay? I encourage it, okay? If you have questions, let me know. If not, you guys did a great job. I'll see you later.